Okay, our last graph on this page is called a piecewise function, and so we've talked a little bit about piecewise functions before, but I've never asked you to graph one. I'm not going to ask you to graph one in this class either, especially in multiple choice format, which you're expecting here, but I do want to show you how it works, how we graph it, and then how to analyze the limit of it, and I've already begun a little. So my first function I colored blue, and I said that's f of x equals x cubed. Now what you'll notice about that particular function is right here it tells you that x is equal to 1, and it also tells you that x is less than 1. So I just picked some values that meet that criteria. So I picked 1, of course, and then numbers less than 1 that I could plug in would be 0, -1, and -2. Talking about the 1 for a second, you'll see how it equals 1. So since it equals 1, that means you would have a closed point at 1. Now, so we evaluate those, and when we plug those into the function, we get, if you plugged 1 in, of course 1 cubed is 1, 0 cubed is 0, -1 cubed is -1, and -2 cubed is -8. So let's go ahead and plot those points on my graph. We have 1, 1, 0, 0, -1, -1, and -2, -8. Now the graph has to stop there. Not the most beautiful graph, sorry about that, but the graph has to stop there. It cannot go past, let me color it green for a second. It cannot go past this point right here because that's the cutoff point right here. That would be the cutoff point of that particular piece of the function. So that blue piece only goes for x values less than 1. Right, so let's look at the red one then. The red graph says x is greater than 1, but you'll notice that it won't be equal to 1 because remember, a function can't have two different values at 1x. So since I start it as close as I can to 1 but not include 1, since it doesn't equal 1, you're going to have an open point here. So at 1, 2, so we'll also pick values greater than 1. So for this one, I would pick 1, which would be an open point since x can't equal 1 here. Then you'd pick 2 and 3 and 4 because those are all numbers bigger than 1. When we plug that in, 3 minus 1 would give me 2. 3 minus 2 would give me 1, and that's how we would plug those in. Now let's get ready to graph it. I have the point 1, 2, and that's an open circle right there. Then I have the point 2, 1, 3, 0, 4, -1, and so forth. That's what my graph would look like. Okay, so that's what the graph looks like. Now we are ready to answer our limits. Okay, for the first one, I'm asking you the limit as x approaches 1 from the right. Now, unfortunately, I see that in all my other examples, I started with left first. So you'll see that I started out of order than my customary way, and I apologize for that. But for this one right here, I ask you the plus. See the plus? The plus means I'm going to look at 1, what happens on the right side. Let me change my colors again. Okay, so let's try that again. So again, I'm the plus side, so I'm going to look what happens as we approach 1 from the right side. Okay, so as I approach 1, this is where it's going. From the right side, I'm going to 2. Okay, the other one is a little minus. See the minus here? That means I'm going to be approaching from the left side. That's the blue side. As I get closer and closer to 1 from this left side, that means I'm going to 1. Now the overall question here is, the last one, do they match? They do not match. 1 goes to 2, 1 goes to 1, they do not match, and so your answer for this one is does not exist because they do not match.